Okay, for now we move to the second subtopic, compound with multiple metal carbon bond. Okay, from this slide, as you can see, we have metal double bond carbon. We have two kind of organic compound. Okay, the first one is carbene and the second one is acylidene complexes. Okay, so from the structure, as you can see, we classify into 2A and B. Carbene complexes is B, pose a metal carbon double bond and are closely related to acylidene complexes, which is A structure. Okay, so for the A structure is also renowned as a stroke type carbene complex, or commonly known as acylidene complexes. Okay, for the carbon structure B is a Fischer type carbene complexes. Okay, as you can see from this slide, they have the same kind of center metal ligand carbon double bond, but the difference is kind of functional group. Okay, this one we have alkyl and this one we have ER. Okay, which is E come from the heterogeneous compound. Okay, so how we want to differentiate between compound A and compound B? Okay, from their name. Okay, so for compound A, we known as a stroke. So how to the quick tips how to remember the structure. If our compound have only alkyl group R, okay, you know as a R, okay, from the spelling stroke. Okay, so they have R, letter R, so represent of the alkyl group. Okay, so for the second compound, which is a Fischer type carbene complex, for the B complex, okay, you know differentiate between A and B only for E. Okay, E come from heterogeneous compound, which is OSN. Okay, so like sun, right? OSN. Okay, E. So the name of B compound is Fischer. So as you know, A, B, C alphabetical order. So before F is E. Okay, so meaning that for the Fischer complex, they should have E. Okay, E meaning that they have heterogeneous heteroatom substitute. Okay, which is from SON, sun. Okay, or OSN. Okay, that things how to differentiate, okay, between complexes A and complexes B. Okay, stroke type and Fischer type. So stroke type, compound that have only alkyl group. Okay, alkyl ligand usually have alkyl substitute on a carbon, where for carbene, okay, for the Fischer type carbene complex, usually they have a heteroatom substitute. Okay, heteroatom substitute. So Fischer before F should be they have E. So E from the heteroatom substitute. Okay, sun. So that's simple tips, okay, quick tips how you want to differentiate between stroke and Fischer carbene. Okay, for acylidene or stroke type carbene, only contain only carbon or hydrogen attached to the carbene carbon. Okay, so for if they have a different compound or molecule attached to the carbon, so possibility they have two type of properties for each of the complexes. Okay, so characteristic, okay, there are some distinction between Fischer carbene complexes and stroke type acrylamide complexes. Okay, as you can see from this from the table. Okay, for the Fisher type carbene, typical metal that possibly can form for the Fisher type carbene, they prefer the metal from the middle to late transition metal. Okay, and also they prefer the metal with the low oxidation state. So from the table, you can see all the metal have a zero oxidation state, middle to late transition metal. Okay, this one is an example for middle to late transition metal. Meanwhile, for the stroke type acrylamide complexes, they prefer early transition metal, and also they prefer for high oxidation state. Okay, this one is an example for the early transition metal, and as you can see in the bracket, they have a very high oxidation state. Okay, differentiate between Fisher type carbene and stroke type carbene in terms of metal. Okay, central metal of the compound. Okay, and the second one is substitute attached to the carbon carbene. Okay, for the Fisher type carbene, they prefer at least one highly electronegative negativity heteroatom. Okay, so as I mentioned earlier, like sun sulfur, oxygen and nitrogen, ONS. Okay, so this heteroatom is also recognized as a electron withdrawing group. Okay, at least ada one high electronegativity heteroatom. Okay, and meanwhile for the stroke type acrylamide, they prefer electron donating group. Okay, which is hydrogen or alkyl group. Okay, hydrogen or alkyl group. And for the typical other ligand in complexes, okay, typical other ligand in complexes for Fisher type carbene, they have properties of good pi acceptor. Okay, so they have possibility can have the properties of the good pi acceptor. And for the stroke type acrylamide complexes, they are good sigma and pi donor. Okay, as you can see from the previous from the this one, the number second, okay, second properties, this one is electron donating group. Okay, so untuk for this one is electron withdrawing group. Okay, so of course, if they has a capability to be good sigma or pi donor, so of course they have to obtain the properties of electron donating group. Okay, and the last one for electron count for Fisher type carbene, usually they prefer the electron En through, okay, is 18, and for the stroke type acrylamide is 10 to 18 electron. Okay, now as you can see from the slide, okay, they have mentioned Fisher carbene, okay, found on electron rich, okay, low oxidation state metal complexes. So the properties of Fisher carbene, they prefer middle to late transition metal, which is they have the properties pi acceptor ligand. Okay, so the presence of the heteroatom on the carbon, okay, on the carbon allow us to draw a resonance structure that is not possible for unsubstituted stroke type, because of for the stroke type they only have a alkyl group R. Okay, but for the Fisher carbene they have CON. Okay, SON, SON heteroatom, which is can have the they have properties of electron withdrawing group. Okay, so one lone pair is donated from the carbene to the empty d orbital on the metal. Okay, so this one, one lone pair donated from the carbene, okay, to the empty of D or central metal. Okay, lone pair is back donated from a filled metal orbital into a vacant pz orbital on the carbon. Okay, so metal back donation to the carbon for the C. Okay, at the C, pz orbital on the carbon. Okay, there is competition for this vacant orbital by the lone pair on the heteroatom. Okay, consistent with our second resonant structure. So they have competition because of O also have the electron. Okay, sun or this one from our heteroatom. Okay, also I have extra electron, so they have competition to fill the empty of pz. So possible this carbon can accept electron from metal by back from the metal, and also can have electron from the heteroatom that attached to the carbon. Okay, so overall the bonding closely resemble that of carbon monoxide. So carbon ligands are usually thought of as neutral species, unlike diatomic stroacylidine, which usually lack electron for back donation because they do not have heteroatom. Okay. Okay, so usually a typical question will be asked, which one is more stable? Okay, Fisher type or stroke type is more stable between these two different compound. Okay, so how you want to answer for that kind of question? You have to relate with these three atom pi system. Okay, what is three atom pi system? Okay, so Fisher type carbene complexes is more stable than its stroke type. Okay, so this one is an example. Okay, as you can see, they have this one OCH3, and this one also they have carbon, but bracket we have hydrogen. Okay, so of course this one adalah Fisher type carbene and this one adalah stroke type carbene. So of course Fisher type carbene is more stable. Why? Because of presence of the highly electronegative atoms such as O and S or sun. Okay, attached to the carbon. So they have the possibility to participate in the pi bonding. As I mentioned earlier, they have the competition, okay, to fill the empty pz. Okay, possible electron come from sun, SON, or heteroatom, or possible electron come from pi back bonding. Okay, so resulted in delocalized three atom pi system. Okay, involving the d orbital on the metal. Okay, d orbital on the metal, p orbital. Okay, this one p orbital on the carbon, and also p orbital on the electronegative atom. Okay, for this one. So delocalized three atom system provide extra stability to the bonding pi electron pair that will a simple metal to carbon pi bond. Okay, they have two possibility. Okay, can provide extra stability for the pi electron bonding. Okay, this is we call it as a three atom pi system. Okay, which they involve with d orbital on metal, p orbital on carbon, and also p orbital on the electronegativity atom. So that's why Fisher type carbene complexes is more stable compared to the stroke type complexes.